Hello and welcome to getting started with the SOFiSTiK Bridge and Infrastructure Modeler. In this video, I will show you how to create infrastructure drawings in Revit. We will start by creating sections that are aligned to our axis alignment. These sections are placed along the stationing of the axis. We will use additional dimensioning commands from the SOFiSTiK Bridge and Infrastructure Modeler app to very quickly dimension our cross sections. We use one of our commands to create a plan view based on the alignment. This plan view can then be enhanced with additional grid and grid stations along the axis, which we can then even use to create axis-based dimensioning. We will use one point of our superstructure cross-section to create a list with X, Y, and Z coordinates of this point along our stationing, as well as a longitudinal section which also follows the axis alignment to then create a two-dimensional view which represents the developed longitudinal cut. Last but not least, all of this will come together in one proper shop drawing. We finished modeling our super as well as our substructure in Revit, which means that we can take the next step to talk about shop drawings. Up here we have the shop drawings options that the SOFiSTiK Bridge and Infrastructure Modeler provides. We will start by creating aligned sections. This sections command allows us to create cuts that are aligned to our axis, meaning that the first selection has to be our axis selection. The placements along the axis are already pre-selected to create section cuts. We could also tell the program to create cuts in between specific placements, meaning if I were to select placement 0 and placement number 1, I could tell the program to create a section cut every 2.5 meters, for example. We will not do this in this example. I could create specific cuts along my axis as well. We could orient the sections either vertically to the project, orthogonal to the axis, or we could even consider the rotation of our placements. For this example, I will right-click into here and select None. Keep in mind, this is a typical SOFiSTiK selection method. What I want to do is create appendant stations, one at 50.5 meters. I click the plus icon to add this temporary placement, this appendant station. And I want to create a second one at 79.5 meters. The program will now create two cuts at these stationing values. I could also already assign a section type to the created sections. I will leave it at none though. I click on OK, and immediately the two new sections are available in my project browser. I will start with my section at 50.5 meters. With a double click I can enter the view, and this is now a native Revit cut. The cut patterns of my cut geometry are not assigned yet. How can I do that? I can select my substructure and, for example, change this material assignment here to the same material as my superstructure, which was concrete. So one thing that we have to keep in mind that, of course, this material needs to have a cut pattern assigned to it as well. So I will very quickly click over here into the pattern sidebar and select this line and dotted line pattern. Click on OK, and immediately my cut pattern for this material is available. Now let's talk about dimensioning. We are here in a native Revit view, so we could use the standard dimensioning functionality of Revit to create our dimensions in here, but we can also very simply use one of SOFiSTiK commands. So here you can see with this easy geometry, I can simply use Revit commands. But this comes with a little bit of a caveat. If we have a curved structure, for example, the bottom part of our superstructure, this will vary in depth of the view. What do I mean with that? The cuts in Revit work in a way that we cut vertically through the geometry and then we have a view depth. This is what you can control with the far clip offset over here. If I set it to something like 20 meters, we will see that the height of our section will actually vary along the geometry. If we were to now select our aligned dimensioning command, we can see that here I do have either the reference, or if I use the tab key, I can also select the cut edge. The cut edge is usually the part of the geometry that we want to use for dimensioning, because it's the cut line in the section. This is usually hard to select, because we always have to keep in mind to use the tab key and check down here what Revit actually selects. By the way, I will reset the far clip offset and use one of SOFiSTiK Bridge and Infrastructure Modeler's dimensioning tools. And here in the dropdown, you can already see that we have a specific tool to only select cut edges. With this tool, you can be sure to only select this cut edge for your dimensionings. There are a couple of more functionalities, like the profile dimensions. The profile dimensions reference dimensionings that are already predefined in the two-dimensional cross-section of the superstructure. We can also use element dimensions. This one allows me to select an element and click on Finish, and it will find references and assign dimensioning lines to it. Another quick function to create dimensionings is reference dimensions. This tool allows me to select multiple references via selection box. Keep in mind, down there, Revit always tells us what it wants from us. What does the program want now? It wants me to create, by holding the left mouse key, to create a section box, and all the found references that are within the section box will now be selected. And now the program wants me to tell it where to place the dimensioning. I'll simply click on the left side over here, and you can see here that this corner point, this corner point, this corner point, and this corner point were within my selection, which means that it very quickly created these dimensionings. So a lot of useful tools for creating our dimensionings in a quick and versatile way. Let's move over to our next section. With the knowledge that we have from the previous section, it's an easy task to very quickly create all the dimensionings that are necessary for this view. So I will just very quickly create my references, move them over here, do the same thing for the other side, as well as for our bottom part of this abutment. We can use the same function to create the simple dimensions as well in a very quick way. Let's come back to the 3D view. Because what we want to do with our sections is to place them at a sheet in the end. I want to open one of the standard sheets of Revit here. To get our sheet ready for our drawings, I want to modify it. So I click on Edit Family, and what I want to do is to change the boundaries of my sheets so it can fit more of our drawings in one go. I click on Load in the project, and an easy way to place our sections as well as our 3D view is to simply go into the project browser and drag it into the position where we want it to be showcased. Now we can also work directly in our drawing. I can enter my view via double click, go to the SOFiSTiK Bridge and Infrastructure Modeler app, and continue with my Planview. This is the next option that we want to take a closer look at. The Planview, once again, requires me to select an axis. And it already asks me to create axis annotation and stationing details on grids, as well as what family type is used to create this view. I do not change the settings, I simply click on OK, and immediately my plan view is created. Just very quickly, we want to check our graphics and visibility overrides, because the preset for this template is to not have any annotation activated. We want to go into here, select all, and activate all of them. Click on OK. I will start by creating additional grids along my axis. I select the axis, and this interface is actually in the SOFiSTiK Bridge and Infrastructure Modeler, it's always the same. It always works the same. First up, it will ask me to create my grids at my stations. Click on OK. I don't change any of my settings. And now at station 0, 1, 2, and 3, my placements are now as well represented by the grids. Additionally, I want to use this command once more, select my axis, and now I want to show you how to create grids within the placements. So I choose my placement number 1 and placement number 3, but I also turn off the create option, which means that it will only reference these two stations for creating my grids within the placements. I can select a rule, and actually just having 2.5 meters is fine, but just keep in mind there are different rules that you could select here. I click on OK, and within my placement number 1 and placement number 3, it now created my grids with an interval of 2.5 meters. I now want to add additional information to my grids. I can do this via grid stations. Grid stations, first up once more, needs axis reference to create kilometrization. And now it asks me to select the grids where I want to create this kilometrization information. So I select all my grids and I press on finish. The program now immediately assigns the right kilometrization to every interval of my grids. Additionally, we want to now create axis-based dimensioning along our grid alignment. I click on axis dimensions and the program once more asks me for an axis reference. I select my axis and now it asks me to select the grids and then click on finish once more. I select all my grid elements that I created and I click on finish. The program now wants me to pick an insertion point. I can choose wherever I want to in an aligned position to the axis. And now the program creates an axis-based dimension line. Once the program finished, we can double check our interval that way. So much for the plan view. We can now move back to our drawing. We want to double click into a non-selected view. So now we are in the drawing selection and we can come to structural plans. Now move this axis annotations plan view that we created onto our drawing. Next up, we want to enter into our 3D view and create elevation point information. We can simply click on the elevation points command, and this one now requires me to select a superstructure. So I select my first single span girder, and an interface opens up which already pre-selects the profile family that was selected here. And I can now choose one of the reference points that are defined by the 2D family. I can click onto the points to see a preview, but we can also just right click into here, select none, and select our top left point over here. The preset is to create this height information for the elevation point function at station number 10 and station number 50. I could also give it a specific point along my axis, but I could also use once more the create between placements function, which gives me an interval between those two placements of 2.5 meters. Down here, I have additional options to create information. For example, the preset is only to create the axis height information as well as the point height information. But I could also output an X, Y, and Z table for the coordinates of this point. I can simply select it down here and click on OK. The program now creates a preview of the two-dimensional section, as well as a list of the axis and point elevation, as well as a table for the X, Y, and Z elevation of this point. We now want to place all of them on our sheet. So I come back to my drawing, I exit the 3D view by double-clicking over here, and I now want to place the schedule for elevations of my component, as well as the lateral offset of my component, and the preview of my elevation component. To find it in my project browser, there is a neat trick where I simply enter the view, right-click, and tell the program to find it in my project browser. And the program selected Drafting View Elevations component. I go to my sheet and I want to place it over here to have it represented directly in my drawings. Now I want to quickly show you another neat function of the SOFiSTiK Bridge and Infrastructure Modeler app, which is available in the 3D view. So I double click onto my 3D view and I want to use the Measure 3D button. The Measure 3D button allows me to place a reference point anywhere in my three-dimensional geometry and select the second point to measure the distance in between. You can see that the representation is a simple line, and up here we now have the total length in between those 2 points available. This is just for information, we don't actually need it for our shop drawings directly, but a quick and easy way to measure directly between 2 points. Last but not least, I want to create a longitudinal section along the axis alignment. To do so, I click this button and I select my axis. The way that this command works is it will create a section along any kind of axis alignment, which means that we have to give it a view direction. This could either be the left side or the right side, but I want to select this left edge over here. Keep in mind, this is only to give the program a direction in which way to cut along the axis alignment. I click over here, then the unfolded longitudinal section interface opens up. It asks me what to consider: the vertical alignment, grids, linked models. I could also create with or without detailed items. Why is this a question? Because the view that is created now is actually a two-dimensional view, meaning that it is disconnected from the centralized three-dimensional Revit model. With this option, we can tell the program to either create detailed items or line representations of the three-dimensional geometry. Here we have the option to use parallel processing, meaning to use multi-core acceleration. How is the cut going to be aligned vertically or horizontally? So a horizontal or a vertical cut. I could tell the program to not create my cut from station 0 to station 100, so the length of the axis. I could tell it to only go to station 80, for example. We will leave it as the preset with 100 though, and I will actually unselect it here. The preset is to select all the elements that are cut and assigned to the axis. We could also include external geometries. for example, the background of our bridge, to be included in this longitudinal section by clicking onto Far Clip and choose the elements which should be included by the cut algorithm. I need to click on Select and then select all the elements that I want to include. Can click on Finish up here, and now all these elements will be considered by the program. I click on OK, and the program immediately starts creating this two-dimensional view. Here we now have our developed longitudinal cut. This cut includes all the detailing that we selected, and we can use standard Revit commands to now create dimensioning along the geometry. These elements are now detail items. Keep in mind, this is a two-dimensional view. This is not hosted by the centralized model of the Revit project anymore. Meaning, if there are any changes to my three-dimensional geometry, I do need to update this two-dimensional view manually. This can be done via this drop-down of the longitudinal section cut option to click Update View. I now want to place this view on my sheet as well. So I click on my sheet and I will now move my projection on B section cut onto my sheet as well. Now it's time to clean up our sheet over here. So I select my elements and align them in a way that makes sense here. And I will also change my sheet family for it to fit all my drawings onto it. These are the options that you have to use the SOFiSTiK Bridge and Infrastructure Modeler to create clean and easy 2D drawings for your project. Just one reminder in the end, if you have any questions about the specific functions that the SOFiSTiK Bridge and Infrastructure Modeler uses, you can hover over the command and press F1 to open the online documentation.